Hello everyone, welcome to this channel, the YT University. Today we are going to discuss projectile motion. So I have here a clip of a soccer player that kicks the ball, so you are to observe it, and let's try to define projectile motion based on your observation. Yes, you might be thinking that this projectile that you're talking about is just an object which is propelled through the air and follows a curved trajectory under the influence of gravity. So it typically refers to an object that is launched or that are launched or thrown into mid-air, such as bullets, cannonball, arrows, rockets, or even objects like baseball or stones. Alright, so you might be asking me if dart pins are included. Yes, they are. That's a good example. Alright, so from that, let's try to define and answer the question, what is projectile motion? So projectile motion refers to a kind of motion of an object that is launched into air or space and moves under the influence of gravity and air resistance. Alright, so there are places here in the universe that doesn't have air resistance, like say for example on the moon. And on the moon, the acceleration due to gravity is lower, so you just have to change the values in the equation. Nonetheless, they follow the same path, I guess. Alright, different height, but nonetheless will follow a parabolic path. And there's no other force that acts on the object horizontally. Okay, so it is a fundamental concept in physics and is applicable to various real-life situations, such as the motion of this is a familiar example, a baseball that is being thrown just like that. You pitch it, alright, at an angle. When it is hit, it follows a projectile motion. Alright, so this guy who shoots the ball very well, his name is Stephen Curry. He has a good release angle and quick release, I guess, and that's why he is able to shoot the ball very well. So you will see that this angle is, or launch angle, is very important. All right, especially for military officers. It's how they aim the cannonball or the cannon. All right, so this is an old example. So an ancient example is when people in the olden days use catapult to destroy their enemies. All right, so these are basic concepts of that makes use the examples that makes use the concepts of projectile motion. Okay, the key characteristics of projectile motion includes: one, the horizontal motion. Okay, in the absence of other forces, the object moves with a constant horizontal velocity. This means that the acceleration along the x-axis is 0. This also means that its horizontal speed remains the same all throughout the course of motion. So because of that, we can say that a sub x is equivalent to 0 meters per second. And now we can use the formula to find the speed along the x-axis. Since it's equal, alright, so we can say that v sub x is equivalent to vox or v sub ox. Alright, so and finding the displacement would require us to use the formula x is equal to x sub o plus v sub ox times time. Alright, so these are basic formula that you need to learn before moving forward in the study of projectile motion. Alright, so if it has a horizontal component, it also has a vertical component. This happens along the vertical axis. So this motion is affected by gravity, and yep, the object experiences constant acceleration due to gravity in the vertical direction, causing it to move upward and reach its peak. Meaning to say, in its peak, it has to stop. So because of the interaction of the y component and the acceleration due to gravity along the y axis, and then when it stops, there's no other force aside from the gravitational force that's act on it. It falls back towards the center of the earth. Alright, so because of the force of gravity, the value of the acceleration along the vertical axis is negative 9.8 meter per second squared. That is also equal to or equivalent to negative g. Alright, so why is there a negative g right here? So negative sign indicates that the force field acting on the object is conservative, and sometimes it tells you about the direction. Alright, so you just do not put the negative sign whenever you want it, so there is a meaning behind it. You must be sharp that the symbols means something. Okay, so let's move on. For the value of the velocity along the y-axis, we can use the formula v sub y, or velocity along the y-axis, is equivalent to v sub oy minus gt. Alright, so this is a formula coming from the study of free-fall motion. If you haven't watched that video yet and learned that prerequisite, kindly go back before proceeding, because you might be having difficulty in understanding the projectile motion. Alright, so if you are able to master that, now you can proceed. Okay, so the distance along the y-axis from the ground, alright, so this formula is also equivalent to finding the height of the projectile, is given by the formula y, or it will be h later on, or the height is equivalent to y sub o plus v sub y, v sub oy times time minus 1/2 gt squared. So these two came from the free fall motion, or the study of free fall motion, free fall concept. So be sure that you learn them. Okay, I'm gonna put the links in the description box where you can find the video, and also the link of the slide presentation, so you'll be having a copy of this as we move forward. Alright, so let's go. We have the horizontal component, vertical component, and now when you mix the two, it will have a parabolic path. So the object will have to travel a parabolic path. Why? So just like this kid shooting the basketball, so when you shoot it, he shoots it, there's a parabolic path that is being traced by the basketball. So this happens because of the combination of the object's vertical and horizontal motion. So this results in a curved path known as the parabola. Alright, so we have the velocity components. So you must be very familiar with this. Okay, so this g here is confusing. So that should be g, or negative g, which is the acceleration due to gravity, and you will see that this red arrow is upward. This signifies or represent the vector of the velocity of the ball along the y-axis. Alright, so here you will see that the arrow do not have are pointing opposite the other. That means vector subtraction, okay, is done. Okay, there will be a point in time wherein the acceleration due to gravity will be able to cancel out the velocity along the y-axis, and it will stop. Okay, that happens at its maximum height. Okay, so yes, and here this blue or dark blue arrow represents the muzzle velocity. Okay, sometimes you will see a notation v sub o for this one, and here this light blue arrow is what you call the velocity along the x-axis, or sometimes v sub ox. This one is constant, and you will see here the angle theta. Okay, so as I've mentioned, the vertical component is affected by gravity. Okay, so this one, x component, it's also an observable fact that the object or the projectile shadow is moving parallel to the horizontal axis, and hence this can prove that the projectile has a horizontal component. So let's just draw a sun right here. So Mr. Sun, it's not an egg, it's a sun, it's shining bright. Alright, so let's see, the ball is somewhere at some point in time. Alright, so when you draw a shadow, so yeah, we'll cast a shadow somewhere here. So wherever the ball is, the shadow moves, and when you describe the motion of the shadow, so it has a constant velocity. Okay, so Vx here, this one is constant. Okay, so I have here the illustration or an animation that can simulate the projectile. Alright, so I use Cartesian coordinate plane just to track the movement of the projectile. Alright, so let's go. So this one starts from the origin. You kick the ball from the origin. So let's just pretend that this right here is a building. Alright, so somewhere it's gonna catch the ball here, but it missed it, so it's gonna fall far away. Alright, okay, so when you kick it, there's a velocity component along the y-axis. Okay, so why is it like that? So he missed the ball right here, but it will continue moving as what the free fall equation dictates. So you will see that the direction changes. So it's here, it's positive, so at its peak there will be 0 meters per second. So at its peak it will change sign from positive to negative. Okay, so the velocity along the x-axis is constant. Okay, so if the velocity here is v sub ox, is constant all throughout. There you go, there are the arrows, and here you have here the muzzle velocity. Okay, there you go. So the angle at which the muzzle velocity is fired is not changing. Okay, so the acceleration is always directed towards the center of the earth, and you will see that at its peak right here, so this is the peak, the muzzle velocity and the acceleration due to gravity is perpendicular to one another. So that's why it start curving. Okay, that's the peak of the trajectory. At that point in time, the velocity of the ball or of the projectile is equivalent to 0 meters per second. Alright, so that peak from the ground, so when you draw a perpendicular line to the ground, that's also the height of the object away from the ground. So we have the formula for that. I'm gonna teach you how to solve for that later on, and let's move on. So here are some important notations that we should be familiar with when deriving the formula for the projectile motion. Okay, so these notations have meaning and concepts behind them, so they are as follow. So initial velocity is also called the muzzle velocity. So let me just go back there. Here the muzzle velocity or v sub o is not equal to v sub y. Alright, and this is not equal to v sub ox. Alright, so do not be confused with that. So we will be trying to figure out y, and we will solve for an equation that can determine the velocity component along the y-axis and velocity component along the x-axis. Alright, so moving on. Okay, so the initial velocity is also called the muzzle velocity. Initial velocity along the x component is read as v sub ox, which is equivalent to v sub o cosine theta. Alright, so we're going to be using trigonometric function in order to solve for this. Later on, I'm going to show you that. And remember, as I'm telling you from the start, the x component or velocity along the x-axis is constant. This means that it is not changing throughout the course of motion. Alright, so initial velocity along the y component is read as v sub oy. This is computed using the formula v sub o sine theta, and this is changing in magnitude and direction. So the angle theta is constant all throughout, and don't forget that at the same height the velocity is equal but different in direction. Okay, so we also note that the time it takes for the bolt or projectile to reach its maximum height is also equal to the amount of time that the projectile needs to go down. So the total time of flight is equivalent to twice time to get up. So we're gonna show you how to compute the time to get up later on. So moving forward, so projectiles moves into dimensions and it creates a parabolic path. So this is the parabolic path, and you will see that there is an interesting triangle right there, and we're gonna use trigonometric function in order to find the vertical and horizontal component. Okay, so using the help of, or with the help of, angle theta. Okay, so we can get the component velocities of the projectile using the angle and the trigonometric function of sine and cosine. Okay, so let's find that using this triangle. Alright, so the key here in getting the concept is paying attention to theta. So the side of the triangle close to theta is what you call the adjacent side. I'm gonna write here. And the side furthest away from the angle is what you call the opposite side. Alright, so this is the opposite side. So in the context of projectile motion, this is equivalent to v sub oy, or the y component, and this one is your equivalent to vox, or the x component. Alright, and here sine theta is the relationship between the opposite side and the hypotenuse, or of VOY and V sub O, or this is in the context of the projectile, this is the muzzle velocity. Okay, and for the cosine function, this is the relationship of the adjacent side, or the over the hypotenuse, or it can help you compute for the x component and the muzzle velocity. Alright, so let's go and try to do that. So now, replacing it with the concepts that we learned that we need for projectile motion, we have this v sub o, v sub x, and v sub y. Alright, and we can now use cosine theta, and that is equivalent. Alright, so and sine theta. So we'll start with cosine theta first. So this is equivalent to horizontal, or x component, or the adjacent side, which is equivalent to v sub x over hypotenuse. Okay, there you go. So that's the hypotenuse, and this is equal to v sub x. Alright, so all the velocity along the x-axis all over v sub o. So you're gonna find the v sub x here. Okay, you're gonna make the formula or relationship. So this will be equal to cosine theta is equivalent to v sub x all over v sub o. Multiply both sides by v sub o. So thing here is v sub o here will cancel out. Okay, and then you have a new formula for the velocity along the x-axis is equivalent to v sub o cosine theta. So for the y component, we can solve it using the sine function, and this is equal to the vertical, or the opposite side, over the hypotenuse. So that's the vertical component, and then, or the opposite side, and then the hypotenuse. Okay, and this is equal to v sub y all over v sub o. Alright, so you're gonna have sine theta is equivalent to v sub y all over v sub o, and then again multiply both sides by v sub o, so that it will be transposed to the other side. This one will cancel out, and you're gonna have v sub y is equivalent to v sub o sine theta. So these two formula are needed for you to find out and look for, and be able to determine the velocity along the x-axis and velocity along the y-axis. So let's move on. Okay. So as mentioned earlier, the y component is affected by the acceleration due to gravity. So this requires us to use the concepts of free fall, okay, or the free fall concepts that we have learned from our past discussions. So we need to know the initial and final velocity component along the y-axis using the sine function, and it can be related to the time. Okay, so here let's make the athlete kick the ball. Yeah, kick it. Come on. So there you go. He kicked, and we tried to pause for a while because um, you will not be aware of that, but it stopped at its maximum height. Okay, then, so the y component here is v sub oy is equivalent to v o sine theta. Then it's also affected by gravity. Okay, and then it will fall back to the earth. So yeah, so we said it's gonna stop there, so that's why it stopped. Okay. So there you go. So we use the concept that we learned from free fall motion. So here we have a formula here, v sub y sub f. So this is actually the final velocity. So and then here is the initial velocity. Okay, so you need the time to get up. Okay, and this is the formula. So g here is the acceleration due to gravity. So at its maximum height, okay, up to the maximum height, time to reach the maximum height, so the velocity is equivalent to 0 meters per second. Okay, so this one is the 1/2 gt squared. So that is another formula, but this one is involved in finding the height. Okay, and yep, we'll start with the derivation of the formula here. Okay, so here b sub y sub f is equivalent to 0 meters per second. So this formula can be reduced to T up is equivalent to negative Vy sub I minus I all over negative G. Okay, so I'm gonna substitute the value for V sub Y, and that is gonna be V sub O sine theta. So that's gonna be time to get up is equivalent to V sub O sine theta all over G. So you will see that the negative sign cancel out because negative divided by negative is positive. Yeah, we now wish to find the maximum height of the projectile above the ground. Hence, we can use the freefall concept to get the height using the value of time to get up, or T up. So we use the formula h is equal to d, wherein h signifies the height. This one is height. Alright, and yeah. This is positive negative 1/2 gt squared. So I include there the positive negative because it depends on the axis where you are calculating. Okay, you start solving. So but most of the time we use the positive sign because the meter, okay, so it has an absolute value of positive. That's why I try to use it positive. Okay, so the sign depends on the orientation from the origin or the reference frame of the observer. But since we are talking about the height, it should be positive. Okay, so we'll start from that formula. Okay, and then we're going to substitute the value of t up here in t squared. Okay. So you have h is equivalent to 1/2 g times v sub o, okay, sine theta all over g squared. So you will see here you have to square it first. Okay, so you're gonna have g squared, and then one will cancel out. Alright, one will cancel out. So this one will cancel out. There should be a cancel sign there also. Yeah. And then we have VO squared sine theta all over G over 2G. Okay. Yep. So this is just equivalent to v sub yi squared all over 2g. So those are the formula you need for solving for the height and the time to get up. Okay, now solving for the range of the projectile. How far did it go? Okay, range is the distance traveled along the x-axis, and if, okay, so the time to get up is equivalent to the time to get down. So you add the two time, or you're gonna have the formula twice. The time to get up is equivalent to the total time of travel. All right, then you're gonna use this total time and multiply it to the constant velocity along the x-axis, and then that's it. Okay, so d here, or you can use r, okay, is equivalent to d, or distance along the x-axis is equivalent to v sub x sub I times 2t up. Alright, so if you have the value, you can just multiply it, and you can just multiply it to the velocity along the x-axis. So we're gonna substitute the value for v sub x sub I. That's gonna be v sub o cosine theta times twice the time to get up, and substitute the value for the time to get up here. That's equal to VO sine theta. So you're going to simplify this trigonometric identity. You're gonna have VO squared uh, times 2 sine theta cos theta all over G, or VO squared sine 2 theta all over G. So you might be asking, oh, why sine theta cos theta turned into sine 2 theta. So it's a trigonometric identity. The proof can be found in the book of Paul Ryder, or you can prove it by yourself using the table. Okay, so we are able to find the time, we are able to find the height, and we are able to find the distance. I think that's all you need for solving the projectile motion, or problems regarding the projectile motion. Okay, so that's it for this video. We're going to do the practice next time.